Okay, so this video is about how to calculate your percent yield for making aspirin from salicylic acid and acetic anhydride. So the percent yield tells you how efficiently you made your product. The percent yield is a ratio of what's called the actual yield to what's called the theoretical yield. And then because it's a percent, you times that, you multiply that by 100. So the idea is that the actual yield is what you actually got. It's the amount of product that you actually got at the end of your experiment. So that's going to be different for every person who performs the experiment. People who perform it more efficiently will get more. People who perform it less efficiently will get less. And the actual yield is something that you would have measured in our experiment in step 67. So you should have a picture of the mass that you weighed at the end of the experiment, of how much aspirin your group had, and that would be the picture you took from step 67. So that's how much you made. But the percent yield is not just how much you made, it's a ratio of how much you made to how much you could have made. How much did you make out of what you could have made? And that's what the theoretical yield is. The theoretical yield is how much could you have made if you were perfectly efficient. If every molecule of salicylic acid reacted with a molecule of acetic anhydride, and anytime you transferred the contents from one beaker to another, it all transferred, every single molecule, how much aspirin could you theoretically have made in your experiment? That's what the theoretical yield is. So that's what we need to calculate in order to figure out what the percent yield is going to be. So once we have this theoretical yield, we could figure out how much of that we actually made, and then we could make a percent that describes how efficiently we performed the reaction. For example, if our percent yield is 40%, that means we made 40% of what we could have made if we had done the reaction more efficiently. So how do you calculate this theoretical yield? That's what we have to do now. The theoretical yield is the maximum amount of product that you could have made. That is limited by the reagent you have that ran out first, and that's called the limiting reagent. So we have three reagents here, well, really two. We have the salicylic acid and this acetic anhydride that we mix together, and then we have another thing that kind of looks like a reagent, but it isn't one. It's a catalyst. That was the phosphoric acid. So that doesn't get used up in the experiment, it just makes the reaction happen faster. So the concentration stays the same, it just speeds the reaction up. That's a catalyst. So the only two things that are going to get used up, the only two reagents we have are salicylic acid, which comes from willow bark, and then acetic anhydride. So the one of these that runs out first limits how much aspirin we could make. That's called the limiting reagent, and in our experiment, that was salicylic acid. So if you're ever trying to figure out what the limiting reagent is on your own, you would look at how many grams of salicylic acid you use, you'd convert that to moles. You'd look at how many milliliters of acetic anhydride we used, you convert that to grams using the density, and then from grams to moles. And because this is a 1-to-1 ratio, whichever one has fewer moles, that's your limiting reagent. For our experiment, that's salicylic acid. So that's our limiting reagent. And so the first thing you'll want to do is to look at how much salicylic acid you used. That's going to limit how much aspirin you could have theoretically made. You would get that in our procedure from step 15. So step 15, it was you took a picture of how much salicylic acid your group weighed out. So everyone weighed out a slightly different amount. Look at how much you weighed out in step 15. That will give you a grams of salicylic acid. And ultimately, we want to convert that to grams of aspirin. How many grams of aspirin could you have theoretically made? Now, anytime you go from grams of one thing to grams of another, so let's say A and B, anytime you go from grams of one thing to grams of another, you should always follow this sort of flow chart. You go from grams of the first thing to moles of the first thing, moles of the first thing to moles of the second thing, and then moles of the second thing to grams of the second thing. So in our particular scenario, the thing that we're starting with, salicylic acid, I'll write that in. I'll replace A with that. So we're going to go from grams of salicylic acid to moles of that same thing, salicylic acid. Then we're going to go from that to moles of the second thing, aspirin, acetyl salicylic acid. And finally, we'll go from moles of aspirin to grams of aspirin, acetyl salicylic acid. Okay, now each of these arrows represents a conversion, and in order to do any conversion, you need a conversion factor that relates the two units. So for example, how do grams of salicylic acid relate to moles of salicylic acid? We have to know that if we want to do that first conversion. Anytime you relate grams to moles, you can use what's called the molar mass. That's the mass, how many grams there are in 1 mole. So you always put the number 1 next to moles when you're relating grams to moles. You can find the molar mass using either the periodic table, or you could look it up either online or in a chemistry handbook like the Merck Index or the CRC handbook. If you were to look it up or calculate it, you would find that the molar mass of salicylic acid is around 138.121 grams. So that's how many grams of salicylic acid there are in 1 mole of salicylic acid. So you would use this conversion factor to do this first conversion. For the second conversion factor, the second conversion, you need to relate the next 2 units. So how do moles of salicylic acid relate to moles of aspirin? When you're relating moles of one thing to moles of another, you use the coefficients in the balanced chemical equation. So we'll look up at the equation for the reaction we did, and you're looking at salicylic acid and you're looking at aspirin. And specifically, you want to see how many moles of this are used and how many moles of this are made. If you look to the left of the compound, you'll see there are no numbers written in. It's not like there's a big 2 or a big 3 there. So there are no molar coefficients. If no number is written in, there's an implied 1. So the only time a number wouldn't be written in is if there's an implied 1. And what that means is for every 1 mole of salicylic acid that you use, you'll get 1 mole of aspirin in this reaction. So the ratio is for every 1 mole of salicylic acid that you use, you'll make 1 mole of aspirin. So when you relate the mole of one thing to the moles of another, you get the coefficients, you get those numbers from the coefficients in the balanced equation, that 1 and that 1 there. So that's our second conversion factor. The third arrow is our third conversion, so we need a third conversion factor. So in order to do that conversion, we have to know how moles of aspirin relate to grams of aspirin. Just like we saw earlier, anytime you relate moles and grams, you use the molar mass. That's the mass, the number of grams, for 1 mole. So what's the molar mass of aspirin? You could calculate this from the periodic table. You could look it up online, or you could look it up in a handbook like the Merck Index or the CRC handbook. If you were to look it up, you would find that the molar mass of aspirin, acetyl salicylic acid, is 180.158 grams. So if you weighed out that many grams of aspirin, you would have a mole of aspirin molecules. Remember, that's 6.022 times 10 to the 23rd molecules of aspirin. Okay, so that is our third conversion factor that will allow us to do our third conversion. So once you have all those 3 conversion factors, we can do the conversion. You would take the amount of salicylic acid that you weighed out in step 15. So you have a picture of that from step 15. How much salicylic acid did you weigh out? So you'll take that, and that will be your starting point. That is what's going to limit how much aspirin your specific group can make. So you have that certain amount of salicylic acid. Every time you do a conversion, you write a multiplication sign, a fraction bar, and the units that you start with are going to go on the bottom of that fraction because you want them to cancel out. When you do a conversion, you want the units to change. So that means the units you have to cancel out. So you're going to fill in that first fraction with our first conversion factor. So next to grams of salicylic acid, we'll put 138.121. Going over the fraction bar is like going across the equal sign. So on top of this fraction, we'll have 1 mole of salicylic acid. Notice how grams of salicylic acid cancel here, and we're left with moles of salicylic acid. But we don't want moles of salicylic acid. We want to know how many grams of aspirin we could have theoretically made. We're looking for the theoretical yield. So that means we need to do another conversion. Every time you do a conversion, you write a multiplication sign, a fraction bar, and the units you start with on top of your fraction, you want to put those units on the bottom of the next fraction. So moles of salicylic acid will go on the bottom here. And we want to do that because we want those units to cancel out. If they don't cancel out, they can't change. So we're going to fill in this second fraction with our second conversion factor. Next to moles of salicylic acid, we'll go 1. Going over the fraction bar is like going across the equal sign, so on top of the fraction we'll have 1 mole of aspirin. Notice how moles of salicylic acid cancel out. We're left with moles of aspirin, but that's not exactly what we want. We want grams of aspirin. We want to know how much aspirin could we have made with this amount of starting salicylic acid. So if you have one unit but you want a different one, you have to do another conversion. Every time you do a conversion, you write a multiplication sign, a fraction bar, and the units you start with in the previous fraction go in the bottom of the next one. You want those units to cancel out so that they'll change or convert. We're going to fill that third and final fraction in with our third and final conversion factor. So next to moles of aspirin, we'll go the number 1. Going over the fraction bars, like going across the equal sign, on top we'll have 180.158 grams of aspirin. Notice that moles of aspirin cancel out and we are left with grams of aspirin. That's exactly what we wanted. So when you calculate this all out, you'll have grams of aspirin, and that will be your theoretical yield. That's theoretically the maximum amount of aspirin you could have made when you started with the grams of salicylic acid that you weighed out in step 15. So once you have that theoretical yield, you can go back and plug it in. This is what would go in the bottom of the percent yield formula. So when you have this, that's the maximum amount of aspirin you could have made. We're looking for the percent yield, how much you made compared to that. So you'll take the amount of aspirin you weighed at the end of the experiment from step 67, you'll divide it by that theoretical yield we just calculated, and to make it a percent, you'll multiply by 100. That will give you the percent yield for this experiment. And the percent yield tells you how efficiently you performed the experiment. If you have an 80% yield, that means your group made 80% of what you could have theoretically made. If you have a 20% yield, your group made 20% of what you theoretically could have made. So hopefully this video helped you a little bit with calculating the percent yield for making aspirin from salicylic acid.